NASA gave an earnest admonition: Pluto is not what you think. What is NASA implying here? Are they alluding to the most recent discoveries from the New Horizons space probe, which show that odd things are happening on Pluto's surface? One of the intriguing pictures even shows an object that seems to be skimming across the outer layer of Pluto. This raises unsettling questions about whether some sort of previously unknown life exists on this distant world, or if we are dealing with a bizarre topographical peculiarity. Pluto might be small, but the stories it has to tell are big and full of surprises. When Pluto's planetary status was revoked in 2006, scientists were unaware of the data coming from the New Horizons probe, which only reached Pluto 9 years later. Since then, we've learned that there's much more to this little body than was initially believed. But how did astronomers come to deny Pluto's status as a true planet, something most of us had grown up with? The decision followed the discovery of many other small objects in the Kuiper belt. They concluded that we needed a clear boundary for what qualifies as a planet versus a dwarf planet or trans-Neptunian object. Pluto checks many boxes for size and roundness, but it shares its orbit with other objects. Its orbit is therefore not considered cleared, which was the reason for its reclassification. This decision shocked many people, who simply could not accept that this small, familiar object was no longer considered a planet. There were protests, letters of dissent to NASA, and even angry letters from citizens requesting Pluto be reinstated as a planet. For many, Pluto had been part of our solar system's family of 9 planets since the 1930s. In 2015, when New Horizons sent back the first true pictures of Pluto, it was a magical moment, seeing this small, once-rejected dwarf planet for the first time up close. Those early pictures of Pluto were revolutionary. Until then, Pluto's image had been speculative, often appearing only as artistic renderings in textbooks. Even Hubble could barely make out its shape. But when New Horizons arrived, it sent back stunning, detailed images that showed Pluto as more than just a frozen rock on the edge of the solar system. Instead, it was a colorful, energetic world with a heart, and that image melted many hearts. The New Horizons mission uncovered that Pluto was far more varied, organized, and dynamic than scientists had expected. What they discovered was breathtaking. Pluto was not the frozen, cratered wasteland they imagined. Instead, it was a world with vast ice plains, deep canyons, and smooth, icy surfaces. Over time, more data from New Horizons has continued to surprise scientists with new aspects of Pluto's geography and atmosphere. In 2016, a particularly eerie image circulated, showing what appeared to be a figure walking across a bizarre, honeycomb-shaped snowdrift. While it looked like an individual was walking on Pluto's surface, closer inspection revealed that the person was actually an ice formation, a large block of frozen nitrogen. Scientists identified it as a floating ice block, which likely forms through geologic processes beneath Pluto's surface. This discovery revealed that Pluto is far more geologically active than previously thought. Scientists now suspect there's a nitrogen reservoir beneath the surface, and this internal heat pushes ice blocks to the surface, creating patterns like the ones seen in the image. The presence of a warm, active interior suggests Pluto is not just a dead rock but a world with an internal dynamism that could have implications for our understanding of how other distant objects in the solar system work. It's possible that Pluto harbors pockets of liquid beneath its surface, in the form of seas or even ice magma chambers. William McKinnon, the lead member of the New Horizons geology team, even compared Pluto's internal dynamics to that of an astrolite the size of Hudson Bay, Canada. Computer simulations show that Pluto's surface features, including ice mountains and deep valleys, could have formed over millions of years and remain active today. Could life exist on Pluto? While we have no direct evidence of life, the existence of liquid under the surface and the geologic activity suggests that Pluto is far from the inert, frozen body we once thought it was. The possibility that Pluto has active processes, similar to those seen on other icy worlds, makes it a much more intriguing and dynamic place. Another fascinating discovery was Pluto's atmosphere. Even though it's thin, composed mainly of nitrogen, methane, and carbon monoxide, NASA found that it undergoes significant seasonal variations. Pluto's eccentric orbit and tilt cause its atmosphere to change dramatically depending on its distance from the Sun. These changes further suggest that Pluto is a much more complex and active world than we had ever imagined. So, when NASA says that Pluto is not what you think, they're urging us to reconsider everything we thought we knew about this distant, icy world. With each new revelation from New Horizons, Pluto is proving to be a far more remarkable place than anyone could have anticipated, full of surprises and secrets that continue to challenge our understanding of the solar system's outer reaches. Sun, the progressions influence not just the air, yet additionally the surface states of the Bantam planet. One especially astounding part of the climatic elements is snow on Pluto. This comprises essentially of frozen nitrogen and methane, not at all like on Earth, where snow forms only from water. The incredibly low temperatures on Pluto cause the increasingly volatile gases, nitrogen and methane, to condense and fall as outlandish snow. All these cycles shape and restore Pluto's surface by covering the landscape with new deposits. The disturbances, thus, drive other land movements in the form of icy expansion and potentially even cryovolcanic processes. The New Horizons examination also showed that these seasonal cycles are closely connected to atmospheric thickness. When Pluto is closest to the Sun, the thin light is enough to heat up the dwarf planet's atmosphere, making it expand slightly and rise. When Pluto moves away from the Sun again, the atmosphere freezes and sinks back to the surface. This phenomenon triggers a major event. When Pluto's atmosphere gathers, it could literally snow, with the snow consisting of nitrogen and methane. The variations in surface brightness and the distribution of frozen deposits further suggest that nearly all surface features and scenes on Pluto are tied to these atmospheric cycles. Since Pluto's mountains are not made of rock, but of ice, which is very dynamic in this world, the entire surface moves significantly more than that of Earth. For instance, what is Pluto's heart made of? Who would have believed that Pluto's heart isn't just a lovely brand name? In addition to its renowned appearance, this area is also one of the most exciting regions on the planet. Formerly considered Sputnik Planitia, the region is named after the first artificial satellite, Sputnik 1, which the Soviet Union sent into space in 1957. This enormous heart-shaped ice surface extends over an area of around 1,000 kilometers and consists primarily of nitrogen ice with inclusions of frozen methane and carbon monoxide. The bright, almost fluorescent surface of Sputnik Planitia forms a sharp contrast to the darker, more complex areas around it. Geographically, Sputnik Planitia is a colossal impact structure that was likely later modified by volcanic processes. Unlike normal volcanic activity on Earth, where magma rises from the planet's interior, cryovolcanism on Pluto involves icy materials rising from the dwarf planet's interior to the surface. The heat sources in the depths of Pluto cause nitrogen and other volatile substances to warm up and push upwards, where they freeze and form special developments like this one. Sputnik Planitia is remarkably flat, which leads specialists to suspect that the frozen surface is consistently replenished by internal processes. It's likely convection processes inside the ice sheet that shape these scenes. Scientists suspect that there might be an expanse of liquid water beneath the smooth ice sheet of Sputnik Planitia, which is kept liquid by the heat inside Pluto. Researchers wonder whether forms of life could exist in this subglacial sea. However, it's not entirely out of the question. Which role does Charon play? What barely anybody knew before New Horizons' mission is that Pluto has its own moon. Moreover, not just one, Charon is Pluto's largest moon and was discovered in 1978. With a width of around 1,212 kilometers, Charon is so large that it forms a highly intriguing binary system with Pluto, as the two bodies rotate around a common center of gravity outside Pluto. Scientists now suspect that Charon is not a true moon at all but rather also a dwarf planet that somehow became gravitationally bound to Pluto. This unique pairing has significant consequences for both celestial bodies. For instance, the gravitational interaction between Pluto and Charon leads to tidal forces that affect their surfaces, and possibly even their interior structures. These forces may be responsible for Pluto's warm interior and the exciting geologic activity it displays. Charon's impact also affects Pluto's tilt, both bodies are tidally locked to each other, so they always face the same side. Charon could impact some of Pluto's atmosphere by capturing ejected atmospheric particles. Charon itself does not have a permanent atmosphere of its own, but it likely temporarily captures volatiles from Pluto's atmosphere and thus envelopes itself in a mantle of its partner's volatile material. NASA's New Horizons mission has set planetary scientists abuzz, highlighting a significant shift in our understanding of this distant world. For years, Pluto has captivated our imagination. Its status as the 10th planet in our solar system became embedded in our collective consciousness. However, recent discoveries from the New Horizons space probe have challenged everything we thought we knew about this enigmatic world. The journey to reconsider Pluto's status began in 2006 when the International Astronomical Union, IAU, controversially reclassified Pluto as a dwarf planet. This decision, driven by the discovery of other similarly sized celestial bodies in the Kuiper belt, sparked a wave of debate and disappointment among scientists and the public alike. Many argued that Pluto's downgrade diminished its importance and historical legacy. However, the true marvel of Pluto lies in its surprising complexity, which continues to intrigue researchers and shape our view of the outer solar system. A defining moment came almost 10 years after the fact with the appearance of the New Horizons test at the edge of our planetary group. Outfitted with cutting-edge instruments and cameras, New Horizons offered mankind its most memorable close-up view of Pluto's surface in 2015. What it uncovered was absolutely surprising. The pictures radiated back to Earth portrayed a universe of faltering intricacy and magnificence, not even close to the frigid, barren badlands some had envisioned. Pluto's surface was bursting at the seams with land movement, great ice sheets, profound gullies, and smooth frigid surfaces indicated a dynamic and ever-changing scene. The discovery of nitrogen ice masses and possible cryovolcanoes challenged our understanding of planetary cycles in the outer reaches of the solar system. One of the most fascinating discoveries was a heart-shaped region on Pluto's surface, aptly named Sputnik Planitia. This tremendous breadth of frozen nitrogen, methane, and carbon monoxide indicated a history of violent impacts and subsequent volcanic activity. The presence of a potential subsurface sea raised enticing questions about the potential for life beyond Earth. Moreover, Pluto's relationship with its largest moon, Charon, added one more layer of complexity to the story. The gravitational dance between these two bodies uncovered insights into their shared history and development. Tidal forces from Charon likely played a role in shaping Pluto's surface and internal structure, further obscuring the line between planet and moon. But perhaps the most amazing discovery came from surprising movement captured on Pluto's surface. Images returned in 2016 showed what appeared to be a huge object crossing Pluto's surface. Further investigation confirmed that it was a dirty ice shelf floating across the frigid landscape, moved by forces from beneath the surface. This discovery tested existing models of planetary dynamics and raised intriguing questions about the nature of geological activity on distant worlds. As scientists continue to pore over the abundance of data returned by New Horizons, the story of Pluto only grows more fascinating. Each new revelation challenges our assumptions and expands our understanding of the universe. While debates about Pluto's planetary status may continue, one thing is clear: this little world at the edge of our solar system holds secrets yet to be fully uncovered. And as time passes, we inch closer to unlocking the mysteries of Pluto and the universe beyond. NASA's ongoing discoveries regarding Pluto have sparked a wave of excitement and speculation within the scientific community. For years, Pluto has occupied a unique place in our understanding of the solar system. However, recent findings have prompted a reassessment of its significance and complexity. The renaming of Pluto from a planet to a dwarf planet in 2006 marked the beginning of a new chapter in planetary science. While this decision was met with disappointment by some, it sparked renewed interest in understanding celestial bodies beyond the traditional boundaries of our solar system. Fast forward to 2015, when the New Horizons spacecraft made its historic flyby of Pluto, capturing extraordinary images and data that would revolutionize our understanding of this distant world. What scientists discovered was nothing short of extraordinary. Rather than the barren, frozen no-man's land once envisioned, Pluto's surface revealed a landscape teeming with geological activity and variety, towering ice mountains, vast fields of frozen nitrogen, and intricate networks of valleys and ravines, painting a picture of a dynamic and evolving world. One of the most striking features observed was Pluto's heart, an enormous heart-shaped area on its surface known as Sputnik Planitia. This expansive region, made primarily of nitrogen ice, suggested a complex history of geological cycles, including cryovolcanism and tectonic activity. But perhaps the most surprising revelation came in 2016, when images revealed what seemed to be a massive object traversing Pluto's surface. Further investigation confirmed that it was a dirty chunk of ice, drifting across the frozen terrain, moved by subterranean forces. This discovery challenged existing models of planetary dynamics and raised intriguing questions about the nature of geological activity on distant worlds. Pluto's relationship with its largest moon, Charon, also provided valuable insights into its evolution and geological history. The gravitational interactions between these two bodies have shaped their surfaces and affected their internal structures, adding another layer of complexity to the story of Pluto. As scientists continue to analyze the wealth of data returned by New Horizons, new questions arise, driving further investigation and discovery. What other mysteries does Pluto hold? Could there be subsurface oceans or hidden reserves of volatile compounds waiting to be uncovered? While the debate over Pluto's planetary status may continue, one thing is certain: the story of Pluto is far from over. With each new discovery, our understanding of this distant world deepens, opening new avenues of exploration and expanding our knowledge of the universe beyond.